Okay, so I'm gonna turn my camera off, but then keep yours on so that you can get your points. If you walk around, will probably distract you. Okay. All right, so today we are doing multiplication and division equations with rational coefficients. Okay, so this 2/3 that's being multiplied with my x here, that's the coefficient. That's the number that's being multiplied to the variable. All right, so we're gonna work at getting rid of that one. Okay, so we're solving one-step equations with fractions and decimals as our coefficients because eventually we're going to get to two-step equations that are going to be involved with our rational numbers, positive and negatives. This is our 5th day of notes if you have been keeping track, which we have 2 pages of notes just because they're going to take some space of showing how to do our steps. But we're only going to do 5 examples. So if you're doing this in your notebook, make sure you have room for 5 examples. Okay, so first let's talk about the decimal coefficient. So when I was to go to solve this, I see that it is multiplication when it has 16 equals 2500 times n. Remember, when we have multiplication, we want to use the inverse operation of division. So I want to divide by my 2500s. And whatever I do to one side, I have to do to the other side. And why am I dividing by 2500s, you ask? Because they cancel out to make 1. And any number times 1 is that number. So I know I need to find out what my n equals. When I go to divide, the bottom number in the denominator goes outside of our division, and the numerator is our divisor inside the box. If it's a whole number, your decimal starts at the end. But I can't divide by a quarter, so we have to move the decimal of the divisor to the right to make a whole number. That should be a review. We learned that in September, October time. So I have to move this decimal point over twice to make it a 25, which means then I can't just leave 16 as 16. We have to move that the same amount and then move our decimal up to the top. So I actually have to change my 16 to 1600. Okay. And then we can do the division part. Okay. I know 25 can't go in 1, 25 can't go into 16, but 25 can go into 160. If I had 6 quarters, that makes $1.50 or 150 pennies. And then I subtract, and I still have a 0 left that I need to bring down. Okay. So I need to keep dividing until I get a 0 at the end. Okay. When I do that, I then look, okay, if I had 100 pennies, that makes $1. How many quarters does it make to take $1? Well, 4. Then I subtract and get 0, and I'm done. So that tells me that my solution is that n equals a 64. Okay. Any questions about how I got my solution before I go into checking work? No? Okay. And my light speed's going crazy. I got some people that are trying to get into something and can't because they're trying to do other classwork. And I have Google Docs locked. Okay. Remember, we always check our work Okay, we have to check it because we make mistakes. We're human. It's bound to happen that we're actually going to make mistakes. Okay, so that is our steps that we always do at the end after finding our solution. And how do I check my work? Well, I rewrite the equation, but instead of a variable, I put my solution. So instead of that n, I put a 64. Okay. Then I actually go through and redo the work. Now, this is the part I'm not going to be upset if you use a calculator. If you know multiplication is not your strong suit and that's where you make a lot of mistakes, bust out Desmos scientific calculator and then do it through there. Okay? But as long as you're showing your steps and you're showing that you know you're replacing the variable with your solution, then you're doing exactly as you should. Now, does that mean every time that we have some type of state test, there's a calculator available? No. So it is important to know how to multiply your decimals, but also make sure you're checking your work. Okay, so if I've had 64 quarters, I want to know, is that going to make $16? It does. Okay, questions on that at all? No, I feel like we lost a bunch of people. We must be kicking people out left and right. Okay, so let's go down to our next one. Right, and like I said, if I ever go too fast, I will post the video. And if you're watching the video as of now, you can pause this whenever you wish. All right, so I see that it's division. This fraction bar tells me it's division. And we undo division with multiplication because they are opposite operations, which is better known as our inverse operation. Then remember, whatever you do to the one side to get P isolated and all by its lonesome, you got to do to the other. Technically, this is a 1P, okay? P is being multiplied by 1 over 75 hundredths. So I need to multiply by 75 hundredths over 1. Whatever I do to one side, I have to do to the other. The reasoning, I have to cancel those out. I want to make a 1 so that then they are equal. Okay. All right, so P equals, well, now I got to do some multiplication. Okay. This part I need to be showing my work on so that I can show you that I do know how to multiply. Remember when we multiply, we actually don't need to line up our decimals. We can put whichever one we think is going to be easier to actually multiply on the bottom. Okay, so when I multiply, I'm actually going to put the 12 on the bottom because I think it's going to be easier to multiply 1 and 2 than 7 and 5. And don't forget about your decimal because that will be needed later. All right, 2 times 5 is 10. 2 times 7 is 14 plus 1 is 15. Now, when I go to multiply by the 1, remember you have to put that 0 in place because now we're multiplying by this 10's place value and not the 1's. 1 times 5 is 5. 1 times 7 is 7. Then I add them. 0, 10, 7, 8, 9. My answer is not 900. That's a lot. 3/4 of 900 is not -12. Okay. Once we are done, we have to count up how many decimal place values we have, which is just 2. So in my answer, I move my decimal 2 times. Then we have to find out, is our answer positive or negative? Remember our integer man? And a lot of kids be like, ooh, well, 12 is bigger, and that's why it's negative. No, it's because of our integer man, and if we have opposite signs, we get a negative answer. Okay. Any questions on that before I actually check my work? Hard to see because oops. Hi, Damien. You missed some of the notes, but the video will be posted later for you to get some of it. We're getting ready to check our answer for example number 2, though. All right, so the next thing I need to do is check my work. Okay. All I have to do is plug in -9 where P is and see if it equals a -12. Okay, so if I have 75 cents times 9, well, that makes 45. Wait, I'm not multiplying, I need to divide. I'm going the wrong way. Okay, 9 goes in the box. 75 cents outside. But I can't divide by 75 cents, so I move my decimal over and make this my 900 then. Because I went from here to there. Now 75 cannot go into 9, but it can go into 90 one time. Then I subtract, this becomes an 8, 5, 1, and 150. So then I have to think, well, if I have 75 cents that I earned 2 days in a row, I've made $1.50. So it took me 2 days to get to that. And because we have opposite signs, we know we have a -12 equal to a -12. Now, could I be used my calculator to do my -9 divided by 75 hundredths? Yes. I know I'm pretty good with my division, so I can do it that way. Okay. Because 9 times out of 10, if you're messing up your multiplication, you're gonna mess up your division. So it's always good if you're going to check your work and show it. And then if you want, use the calculator to double check that you checked your work correctly. Hope that makes sense. All right. If you are ready to move on to the next set, put your favorite color in the chat so I know that you're ready to move on. In the chat, tell me your favorite color once you're ready to go on to our next example. I'd like to know what you guys' favorite colors are. Green, ooh, light blue, I like baby blue. Blue, red, red is my husband's favorite color. We had that for our wedding. Gray, red, green, black, muted brown. What is muted brown? How can brown be muted? I might have to Google that one. I'll do it right now. Ah, that is a pretty brown. Okay, so going on to our fractions. How much we love fractions, I know. Okay, word problem. If you're doing this in your actual notebook, you do not need to write the whole word problem down, but I do want you to do the modeling and the equation part. All right, 2/3 of Chen's homeroom class plans to participate in the school talent show. If 16 students from the class plan to participate, how many students are in the homeroom class? So what we don't know is how many total he has in his class. So that is our variable. We do know, however, that 16 of these kids are planning to do the talent show. Okay, and if that's 2/3 of the class, I'm going to take 16 and split it into half. So that means there's 8 here and 8 here. So theoretically, there should be 8 here. Okay, so that's how we would model this. But how would I write it as an actual equation? Okay, it tells me 2/3 of, and of always means to multiply, of the homeroom, but there is 16 students that plan to do this. So how I would write it, 2/3 times x, because x is what we don't know, how many kids are in the class, equals 16. Okay. Now, normally we'd be like, oh, it's division. I want to divide. But back in September and October, we talked about why we can't really divide by 2/3. It really doesn't work that way. So what we have to do is multiply by the reciprocal. Remember, the reciprocal is flipping your fraction. And then remember, every whole number is a 1. And the reasoning why we do that is because these two here would make a 6/6, which equals 1. So we know they cancel each other out. We write them to show our work, and we cross cancel to show our work. So you're not really just doing it to waste time, it's justifying why we got x by itself. Okay. So then we have an x equals, well, 16 times 3 is 48, and then 1 times 2 is 2. Well, half of 48 is 24. That's my solution part. Okay, so what I need to do after that is actually check my work. And I've had some kids confused today about how to actually check their work. All you're doing is taking that solution and replacing x with your solution. So I rewrite it as my 2/3 times 24. That should equal 16. Okay, I'll give you guys a moment to catch up. See some of you writing. I see some of you on Cami, putting your notes on Cami. And remember, if you need to split your screen, you can do the alt brackets. Okay, so then I'm going to check it. Okay, I'm going to take my 2 times 24, which is 48, divide that by 3. Okay, 3 goes in 4 one time. 3 goes with 1 left over, and 3 goes into 18 6 times. My answer does work. I'll give you guys a moment, and then we'll go down to our next one. And if you're using the text writing on Cami instead of using the, what do they call it, the pen, you can zoom in with the pen so that it makes it easier to write if you don't have your stylus. Sometimes the text way takes a little bit longer. Okay, I'm going to scroll down some, and if we need to come back to this once we're done with our notes, we can come back to it if you need to finish copying. Okay, this one isn't a word problem, but it says 3/4 of x equals a-9. Okay, the -9 is what makes up those 3 boxes. That's my -9. Okay. What we're trying to find is all of this. That is our x. I don't know what that is. Okay. Theoretically, though, if I had to take -9 and split it into thirds, each one of these would be -3, which means then x would equal a -12. Okay, that's the modeling way. Then there's a little typo right here where it says reminders. Instead of multiplying, we want to put dividing. Okay. When we have fractions that we're dividing by, we must multiply by the reciprocal. Then cross reduce, or you hear me say sometimes cross cancel, if possible. And that's just to help so that we're not multiplying such huge numbers. Okay. So if you're doing this one in your line notebook, make sure you have the modeling. And then we're going to do the equation the algebraic way, which is how you're doing your homework tonight. Okay, so I have 3/4 x equals a -9. I want to get x by itself. I want to isolate it. That's the whole purpose of multiplying by the reciprocal, because then it makes a 1 and x is by itself. Remember, every whole number has a 1 underneath. So these cancel. I'm left with x equals something. When we go to cross cancel, you only do it diagonally. Now I look and I see a 1 and a 4. They can't be canceled. 1 only goes into itself one time, and you can't reduce it anyway. But if I look diagonally, my 3 and 9 actually can, because 3 divided by 3 equals 1. So that's the new value of this 3. Then my -9 divided by 3 equals a -3. And that's my new value. So really, we're taking a -3 times 4. After doing all that reducing, it becomes much simpler numbers. Okay. Remember our integer rules? If I have a negative and a positive, I get a negative product. So x should be a -12, which is the same as what I got from my modeling. Okay. So now next, checking my work. Replace x with our -12. A 3/4 times a -12 should equal a -9. Okay. I can cross cancel my 4 and my -12. 4 divided by 4 is 1. 4 goes in a -12 -3 times. So I really have a +3 times a -3. Okay, different signs makes a negative. 9 equals to a -9. Bada bing, bada boom, that one's ready to go. Questions, concerns? James, your lights aren't red anymore. The lights behind you, they were red the other day. Oh, that's fine. Okay. I was confused. It's like, I swear you're the one with the red lights the other day. Okay. Questions then before we go to our next one? No? Good? Awesome. All right. one thing we always say we need to do. Oops. Whatever we do to one side, we have to do the same thing to the other side. That is the one and most important rule out of the equations. That you're always keeping it balanced by doing the same thing to both sides. Okay. All right. So we're going to do this negative 2/3 x times or equals a negative 16/15. Okay. Remember, if you have a fraction coefficient, you're multiplying by the reciprocal. So that means I am flipping my fraction. And remember to keep your negative 2. Even when you come back to the other side, you do the same thing. Yeah, keep that negative. I've made a couple mistakes today where I've left the negative behind. The whole purpose of that, please cancel. Now x equals, well, where can I cross reduce? Okay, when I'm trying to do this, where can I cross reduce? Anthony.
Negative 3 and 15?
Yes, negative 3 and 15. So 3 can go into both of those. 3 goes into negative 3 a negative 1 times, and 3 goes into 15 5 times. What about my 2 and 6? Can they be reduced?
Yes.
What can they go into, Jordan?
A 1 and a 3.
Yes. We're going to divide both by 2. Don't forget we still have that negative here. So I'm going to just put a negative 1 and a negative there. Oh, wait, not negative 1, negative 3. So a negative 3 times a negative 1 makes a positive 3 over 5. That's our solution. X equals a positive 3/5. Okay. Next thing, check the work. Now, because I noticed my negative 6/15 here is not reduced, I'm actually not going to cross cancel my negative 2/3 times 3/5. Okay. I'm just going to go ahead and multiply across. And remember, since we have a negative and a positive, we get a negative product. So no, my answer has to be a negative, which is a good sign because that's what my other is. So then I just take my 2 times 3 to get my numerator of 6, and 3 times 5 to get my denominator 15. And that is exactly what I'm wanting. All right, once you have that copied down, you can go ahead and open your Kami for your homework assignment. And we will look at problems 2, 6, and 7. 7, I will start it, but you've got to finish it. Now, if you're doing one on the paper, if you printed it out and you're doing it on paper, make sure you're turning in the pictures. Some of you keep telling me you're doing it on paper, but then I never get a picture of it. If you need to, split the screen so you have Kami on one side of your screen and the video on the other. All right. So I'm going to go ahead and go to our next homework assignment. Okay. Now 2 looks like just a regular old division problem, but technically this is a 1/5 that x is being multiplied. So to get rid of that 1/5, I'm going to multiply by 5/1. Notice how that still makes it the reciprocal. Just because we multiplied by 5 on Monday, it still makes it the same thing because it still cancels it out. So I have a 1x. Then I just have to take x equals, well, 5 times 12 is 60. And as always, you have to check your work. So I have to take 60 divided by 5. Well, now say I'm not good at my multiplication, but I rock at division. Take 60 divided by 5. I'm correct. 12 times equals 12. That's all I'm looking for when you're checking your work. You're rewriting the equation and you're finding out, did you do your math right the first time? Okay, especially with the negatives. That's a quick way to notice whether you forgot a negative or something else. Okay. When we go to problem 6, they have mixed numbers. Remember, we cannot multiply by mixed numbers. We have to actually turn them into an improper fraction. Okay. Trying to check to see on your camis if you are ready to move on. All right, looking good. All right, and if you didn't get all this, I will come back to it. You'll at the end, you can just ask me to come back. So here's our gruely number 6. Okay, I'll do 6, you'll have to do 5, which is similar, just different numbers. So remember, we have to do the Concord C where we multiply the whole number in denominator and add the numerator. So this is really a 25/6, and I rewrite the equation as improper fractions. Don't forget on the right side to bring that negative down. Okay, so I have to take 3 times 3 to get a 9, add my 1 to get a 10/3. That's what my equation looks like now with having improper fractions. Now I'm ready to start actually solving using my inverse operation, which in this case, we're going to multiply by the reciprocal because we can't divide by division. Remember, whatever you do to one side, you have to do to the other. So both are being multiplied by 6/25. All because I want this to cancel, because 6/6 makes 1, and 25/25 makes 1. So C equals, and then the other side I have to cross cancel. I know a 3 can go into 6 twice. But what about 10 and 25? 10 can't go into 25. Do they have a common factor? What number do you think can go into both 10 and 25?
5.
Yes, 5 is correct. So if I take 10 and divide it by 5, it's really a 2. And then don't forget we still have this negative here. And then take 25 and divide it by 5, and we get 5. So I really look like I have a negative 2/1 times 2/5. Okay? Integer rules, you have a negative and a positive, you get a negative because they're different signs. So negative 4/5 is my solution. But as always, we have to check the work. When I check my work with mixed numbers, I leave them as the improper fractions I made them into be. Otherwise, you're going to repeat the same process twice, and that's more work. We don't like making more work. We're going to work smarter, not harder. So to check my work, I'm going to keep my 25/6. I'm replacing C with my -4/5. And we want to see if that equals a -10/3. Okay. I could cross cancel, or even if I didn't cross cancel, I would get a -100 over 30. And remember, those zeros cancel out. I've had a lot of kids do this today and tell me it doesn't equal because a -100 over 30 isn't the same. I'm like, but really, it is. Okay. Or you could cross cancel and you still get the same thing. Have a -10/3 equals a -10/3. The fractions aren't so scary. We can do them. Alejandro V, are you with us still? All right. Just wanted to make sure. Pretty quiet over there. Okay. I'm going to go ahead and scroll to 7, but if you need me to come back to this one for you to finish copying, just let me know when we get to that one. Okay, I'm going to start 7, but you're going to have to solve it. I just want to remind you how you do decimals. Okay, even though you just have notes over it. A lot of you don't go back and look at your notes. All right, so a -3 15/100 equals a -45/100 times n. Okay, so that's a multiplication between those two. Remember multiplication, we go to division. So I'm going to divide by a -45/100 on both sides. All so that these cancel. I'm just left with my n. Okay. But when I go to divide, I can't divide by 45/100. We can divide by 45 though, which means I have to turn this into 315. Okay. I know 45 can't go into 3. It can't go into 31, but it can go into 315. So we just need to find out how many times can 45 go into 315. Okay. Once you think you know what that answer is, put it in the chat. Okay. You can try to do some mental math. Think of 45 as 40. How many times do you think 40 can go into 300? Yes, 7. 7 is correct. All right, so 7 times 5 is 35, and 7 times 8 or 4 is 28 plus 3 makes 31.